The notes for 3.2a are on solving systems by substitution. Sometimes we want to be able to solve a system without making a graph, and so the substitution method lets us do that. If you want to review some written steps for the substitution method, you can go on ahead and use them here. One of the things that I recommend is that anytime you see that the directions want you to solve a system by substitution, drawing one of these t-tables can really help you organize your work. Keep in mind that they're optional. It's just one way of going through and doing it. Drawing the t-table is going to give you a way to organize the work that you're about to do. Substitution means you're taking something out and you're putting something in for it, kind of like when your teacher's absent and you go to sub. And so the first thing you do is you're going to write each of these equations down on the top on either side. It doesn't matter which one you put first and which one you put second. Usually I just write them down in order. And then you want to look and find one variable that's all by itself on its own side of the equal sign. For these, each of them have a variable that's all by itself on its own side of the equal sign. Here the y is all by itself, and here the y is all by itself. And that means that it doesn't matter which one you put in for which one. I'm going to take this, 2x minus 5, and I'm going to come over here to my other equation, and I'm going to substitute it in for the y. Because if y is equal to 2x minus 5, then I can take out the y and I can put in the 2x minus 5, and the resulting equation will still be the same. 2x minus 5 is equal to, and then I write the rest of this down, x plus 3. So again, all I did was I took the y out, and I put the 2x minus 5 in for the y. Now I have an equation with just one variable, and so I'm going to go through and I'm going to solve that for x. So just working on this part of the column, I'll minus the x from both sides. That'll give me x minus 5 equals 3, and then to finish I'll add the 5 to both sides, so I'll get x equals 8. X equals 8 is just part of my answer. Remember, the answer to these are usually going to be ordered pairs. So if x equals 8 is part of my answer, I still have to go back and figure out what the y part of the coordinate is. And so to do that, I'm going to take this answer that I got for 8, and I'm going to come up here, and I'm going to plug it in for the x over here on this side of the table. So y equals 2 times, plug in my 8 minus 5. Y equals 16 minus 5, so I'll get y equals 11. And so the other part of the answer to my question is the number 11. 8, 11 is the point where these two lines cross. And so anytime you're approaching a problem with substitution, your first step is always going to be to write one equation down on one side of the table and one equation down on the other side. Once you have the two equations written down, then you want to look at both of them and you want to figure out which one has a letter all by itself. On this one, this first equation right here has the y all by itself. So I'm going to take the 3x plus 2, and I'm going to come over here, and I'm going to substitute it in for the y. Because you're taking out the y, you're saying if y is equal to this, I can take y out over here, and I can put this in for the y instead. So that'll give me x plus 2, and then I'm going to plug in the 3x plus 2 for where the y was, is equal to 11. And then this equation over here gives me, it just has one variable in it, which means I can go through and I can solve for x. I'll start by doing the distributive property. I'll do that in black. Here and here. So x plus 6x plus 4 is equal to 11. Then I'll combine like terms. I'll subtract the 4 from both sides. And I'll finish by dividing both sides by 7. So x equals 1 is part of my answer. And I put it first because the x coordinate always goes first. Once I've solved for x equals 1, then I'm going to take this answer here and I'm going to come up and I'm going to plug it in for x over here. So y equals 3 times the one that I just got for my answer plus 2. That gives me y equals 3 plus 2 and y equals 5. So the point where these two lines would cross if you graphed them would be the point 1, 5. On question C, I'm still solving by substitution. So I drew my t-table, and I'm going to go ahead and I'm going to put my two equations on one on either side. Once I have my two equations written down, remember your job is to look at both equations, and you have to figure out which one of them has a letter, a variable, all by itself on its own side of the equal sign. This one doesn't have a variable all by itself on its own side of the equal sign. You see how they're over here together? But on this one over here, the x is all by itself. So that means I'm going to take the y plus 3, and over here, I'm not going to plug it in for the y, I'm going to plug it in for the x. You always plug it in for the letter that was all by itself to start. So I don't need parentheses on this one since the x didn't have a number in front of it. It's going to be y plus 3, plug that in for the x, and then I just write down the rest of this. plus 2y equals negative 6, and then I'll go through and I'll solve for y. Let's see, I'll minus the 3 from both sides, so that'll give me 3y equals negative 9, and so y equals negative 3. Be careful on this one. On this one, you solved for y first, which means that this part of your answer is negative 3, and then once you have that part done, you're going to take the answer that you got here for y, and you'll come and you'll plug it in over here for y on this side. X equals negative 3 plus 3, and x equals 0. So if you were to graph these two lines, the point where they cross would be the point 0, negative 3. That would be the solution to the system. Sometimes when you're solving a system by substitution, there's going to be an extra step that you have to do. And so in example 2, both of these end up having an extra step. But let's not worry about the extra step yet. It says solve by substitution, so I'll write each of these down, one on either side. The reason why this one has an extra step is because if you look at both of the equations, neither one of them has a letter all by itself. Neither one of them has an x all by itself on its own side of the equal sign or a y all by itself on its own side of the equal sign. However, this one's pretty close. On this one, all I need to do is minus the 8x from both sides, and then the equation would be y equals negative 8x plus 12. I'm going to draw a line underneath that right here, because on this equation, you had to fix one of them first. Now this equation has a y all by itself, and so I can take this and I can substitute it in over here for where the y is on this equation. So sometimes you have to do a little work to get one of the letters all by itself first before you can plug it in. But now that it's time to plug it in, I'm going to take out this y that's right here, and I'm going to plug this in for the y. I had to write a little small to fit it in, but that's what I did right there. So I took out the y. Negative 2x stayed negative 2x, plus 3 stayed plus 3, and then the y went out, and this went in for the y. The equal sign stayed equals, and the 10 stayed 10. So now I'll do the distributive property. Negative 24x plus 36 is equal to 10. I'll combine like terms over here, so I'll get negative 26x plus 36 is equal to 10. And then just continue solving for x. Negative 26x is equal to negative 26. And so when I divide on this one, I'll get x equals 1. So x equals 1 is going to be part of my answer. And then to find the other part of my answer, I'm going to take x equals 1, that answer that I got for x right here, and I'm going to come up and I'm going to plug that in right here for this x. So I'll get y equals negative 8 times positive 1 plus 12. That gives me negative 8 plus 12. And so y equals positive 4. If I were to graph these two lines, that would be the point where those two lines would cross. Example number B is another solve by substitution, and so I'll start by writing each of the equations down, one on either side of the t-table. And then once I have them both written down, I want to look at the two equations and figure out which one would be easier to get a letter all by itself, because on this one, neither of the equations has a letter all by itself. Over here, these both have numbers in front of them, so that's going to be a little bit harder, but on this one, I could do just one step. If I subtract the 3y from both sides, this side would turn into x equals negative 3y plus 3, and then I'll draw the line underneath that, because then that would have the x all by itself, and so this could come in over here, and you could substitute that in for the x to solve the system by substitution. And so again, that's what I've done here. I put the negative 3y plus 3 in for where the x was, and now I'm going to solve this equation that just has y's in it to get my answer to the question. Negative 6y plus 6 plus 5y equals negative 5. And so I'll combine like terms. Minus the 6 from both sides. So negative y is equal to negative 11. And then to solve for y, I'll divide both sides by negative 1. And so I'll get y equals positive 11. That's only part of my answer to the question, though. Once I have that, I'm going to come over here and I'm going to plug it in for y to get the second part of my answer. So 11 is the second part of my answer, and now I'm going to find the first part. X equals negative 3 times 11 plus 3. X equals negative 33 plus 3. And so x will equal negative 30. And so for this one, the point where the two lines would cross, if you were going to graph them, would be the point -30, positive 11. When we're solving a system by substitution, we can also get no solution or many solutions as the answer to a question, and so that's what these last two problems today involve. Remember, anytime you see that it says solve by substitution, you're going to go ahead and write one of the equations down on either side of the t-table. And then once you have them both written down, you want to look and see if one of the variables is already all by itself, and it is. This y over here is already all by itself, so I'm going to take what y is equal to, and then I'll substitute it into the other equation for y. So once I have 2x minus 4 substituted in for the y, I'll solve for x. So I'll start here by doing the distributive property. Minus 12 is equal to -12, and then I'll combine like terms over here on the left. What happens with this one, though, is that positive and -6x cancel out with each other. So what you're left over with is -12 is equal to -12. And so now you have to stop and think. There's nothing else to solve on this one. You want to ask yourself, does -12 equal -12? And it does. So the answer to this question is many solutions. Anytime the x's cancel out with each other or the y's cancel out with each other, and what you're left over with over here is something that is true, that means that the answer to that question is many solutions. If these numbers are different from one another, then the answer to the question is no solution. On question B, it's also a solve by substitution, so I'll start by writing one of these down on either side of the t-table. And then once I have them both written down, remember your job is to find one of the letters, the variable that's all by itself. And so on this one, it's the y over here. That's the variable that's all by itself on its own side of the equal sign. So I'll take the x plus 1, and I'm going to come over here and I'm going to substitute it in for my y. So that'll be 3x minus 3 times, plug in the x plus 1, equals stays equals, 3 stays 3. So the y came out and the x plus 1 went in for the y. And now I'll go through and I'll solve for x. So here I'll do the distributive property. And then I'll combine like terms. 3x minus 3x goes away. And so you're left over with -3 is equal to +3. So unlike this problem up here where the two numbers were the same, down here the two numbers are different. And when the numbers are not the same and the x's cancel out, the answer to the question that you write down, I'm going to write it over here, is no solution. In the last problem, many solutions meant that if you graph those lines, they were going to be the same line, and so they would cross everywhere. Down here, though, it's different. No solution means that if you graphed these lines, they would be parallel lines. Parallel lines never cross, and so the system of equations would have no solution. These two types of answers only happen when the x's or the y's cancel out when you're solving.